Hello everyone, I'm Sharanya PS, Assistant Professor, Department of ISC, AJIAT Mangalore. In the previous video lecture, I have discussed about user-defined function, the different elements of user-defined functions like function call, function definition, and function declaration, with different types of user-defined function. In this session, I will be discussing about very important concept, recursion, and different types of this recursion and some of the example program which uses this recursion like factorial and Fibonacci series and binomial coefficient program. First, what is meant by a recursive function or recursion? As we know, user-defined functions are the set of statements that are clubbed together and given with some name, and it is defined by the user. Here, what is that recursion is one add-on to this function. So, recursion refers to the process where the function calls itself repeatedly until some certain condition is met. This condition we normally specify as a exit condition. Till that, the function will be keep repeating. In the sense, here, these recursive functions are a function which calls itself repeatedly until the condition is met, that is exit condition. These kinds of functions we call it as a recursive function. Say if we take it as an example, there is a function by the name fun or fun, and inside that function body or in the function definition, we will call once again the same function fun. That is, here this function, whenever it sees this function call, once again the control will start executing the same function. That is, inside the function definition, once again the same function is called. These kinds of functions are called as a recursive function. That is, here the function will be, this fun function will be keep executing till it reaches some exit condition. That is, as a recursive way, it will be inside the one function, there is one more function. It will be keep repeatedly executing. This is what we call it as a recursive function. If we look into the flow chart here, the functions are represented in this manner in a flow chart with the box. Along with that, we will be specify it is a function. And then here the function name is mentioned. Inside that, there is some condition that we are going to write. And this process, this function will be keep executing till that condition is getting false, in the sense getting reached. After that, it will come out of this and it will be executing the next statement. That is nothing but it will be set of statement will be keep executing in a continuous manner. These we refer it as a recursive functions. Now, the next question is how we can write the recursive function. Here, majorly, we have to consider two basic information. That is, this recursive will help to divide the larger program into a smaller problems. Or if there is a larger complex programs, then we will define a simple function which will perform that operation. Inside that function, we will keep calling that same function. That is, it divides the problem into smaller problems. And one more, here the very important point is how to mention the condition to stop the recursion. Otherwise, what will happen? It may lead to the infinite loops. That is, the function 1 may call once again function like that. The process will be keep repeating. It will not terminate and it leads to the recursive function. So, there's mentioning the stopping condition is also very much important to terminate this recursive functions. If we look into the basic structure, how we will write this recursive function. That is, we can say it as a template. First, here we will be writing the function name, and normally we will mention if and the else block inside this function. In this if, we will specify the termination condition. That is like what we call it as a base condition to stop the recursion in this if condition. And in the else part, that is how we can divide the problem into smaller problem, or this function will be called once again in this else part. This is a normal template what it is followed to define any recursive function. This is what we are writing as a base case, and this is a section where we will be writing the recursive procedure. Now we will try to understand this concept in a better manner by referring to the example. Here the question asked is, write a C program to find the factorial of a number using recursion method. In the previous sessions, I have already discussed in detail about how to find the factorial of a number. Here a small change is, we have to perform the same operation but using the recursive function. So, what is the main logic of this finding the factorial? We already know that factorial of any given number, say for example 4, is nothing but 4 into 3 into 2 into 1. That it will yield the final result. If we look this same concept from the point of recursion. So, let me begin with the set of statements what is mentioned. We have already discussed when we start writing the program by using recursion is two major aspects we have to come across. One is we have to divide the larger problem into smaller subproblems, and one more, we should write the termination condition or exit condition. So first we will try to see the problem into problem to divide into a smaller problems. Here first thing is factorial of 1. We know that factorial of 1 is nothing but 1. And factorial of 2, what is the value? That is 2 into 1. And then factorial of 3 is nothing but 3 into 2 into 1. And factorial of 4 is, as we know, 4 into 3, 2 into 1. From this, can we conclude anything? Is it any similarity we can find, and can we write some conclusion point here? Yes. That is, when we refer to factorial of 2, that is 2 into, this 1 is nothing but the factorial of a previous number, what we have already calculated, that we can write it as factorial of 1. That is, this factorial of 1 is a function that will calculate the factorial of 1. And coming to the next, 3 into 2 into 1. 2 into 1 is the result what it obtained from the previous iteration. That is, factorial of 2 is nothing but whatever the value it computed to. So, we can write it as 3 into factorial of 2. Same way, in the factorial of 4 is nothing but that current number, that is nothing but 4, and one number less than that, that is factorial of a previous number, that we can write it as 4 into factorial of 3. So, by discussing this, we can conclude one point that factorial of n given number is nothing but n into factorial of n minus 1. That is nothing but, here we are calling once again the same function factorial by referring to the previous iteration. That is factorial n minus 1. 1 factorial less than what we are currently finding the factorial. This is what we have considered as a dividing the problem into subproblem. If we analyze it in much more carefully, here we are finding the factorial of 4. That is 4 into 3 into 2 into 1. 3 into 2 into 1 is nothing but the factorial of which one? It is nothing but factorial of 3. That is, we can mention it as a 3 factorial. That is simple terms n into n minus 1 factorial. That is what we have mentioned in this particular case. And coming to next one, that is 4 into 3, and this 2 is nothing but what? 2 factorial once again. Same way this 1 is nothing but 1 factorial. So by referring like this, and here finally 0 factorial what we are referring with. So finally we can conclude that this 4 factorial is nothing but we can calculate by referring to the previous factorials whichever it is calculated. So that we will result with final resultant of 4 factorial. So final conclusion remarks that I do say from this particular slide is, for any given factorial, to find any given number's factorial, we can call that factorial function recursively inside that function. That is one point. Next, coming to analyzing this major one statement what we have written, that is factorial of n given number equal to n into factorial of n minus 1. What does it mean? Suppose if we are finding the factorial of 5, that is 5 into factorial of 5 minus 1. It is normally we write, if we are writing the factorial of 5 is nothing but 5 into 4 into 3 into 2 into 1. 4 into 3 into 2 into 1 is nothing but 4 factorial. So we are calling this fact function once again with the value 4. That is, inside this factorial of 5, we are calling this factorial 4 once again. That is the meaning of this recursion here. Same way, inside this factorial 4, we can refer the factorial of 3 in the same manner. That is, inside this factorial of 3, we can refer factorial of 2, which was already computed in the previous step. The same way, to compute the factorial of 2, we can refer the factorial of 1 function. So, this is how we can refer the function which was already defined recursively inside the main function. So finally we will be resulting with the result. So each time this will be factorial of 4 will compute the value 4, factorial of 3 will compute the value 3, like that it will keep processing. Factorial 2 and factorial 1 will yield the value 1 and factorial 0 will yield you the value 1. And here, one more point that we need to observe is, if we keep repeating inside the main function, if we keep calling the function, then which may not end as a final result. We may not reach to the conclusion. So, in order to terminate that, the second step that we have to follow is, we have to come across with the conclusion or the exit condition. Here, what is the stopping condition? Here, when we reach to the factorial of 0, then we can terminate. That we get to know that we have found the factorial of all the previous numbers and we can stop that. That is nothing but, here if 0 is not equal to 1, in such case we will be coming across the termination point. Or if we write in much more better manner, that is factorial of 1, like if n value is equivalent to 0, it all the time it will be, the value will be equivalent to 1. And if n is greater than 0, then we need to find the factorial by referring to the formula n into factorial of n minus 1. That is nothing but, here when the n value is equal to 0, that time we have to terminate by returning the values 1. This is what we written as a exit condition, and the second statement what we have written is a recursive statement, or what we call it as a recursive function will be written with this particular statement inside that. Now coming to the program, how we can build the code. First thing, inside the main function, we have to call the recursive function. Now, here with the header file, we started the program stdio.h, and the function name here we are writing is a fact, and the return type is a integer, and it takes one argument, that is a n, that indicates to which numbers we are finding the factorial, and this statement is nothing but the function prototype, or we call it as a function declaration. And then we are calling the main function, and inside the main we have defined two, or we have declared two variables n and res result. N is to take the value of a number from the user. We are reading it from the user, and we are using one more variable result to store the final result, which it is computed by the function. And this is what we call it as a function call, that is fact, and we are passing the argument or the parameter n. The function is called from the main function. Next, after we are getting the result by this function, we are printing the result back onto the screen, that is the factorial of a %t given number is whatever it is computed, it will be displayed onto the screen. Now we'll try to figure it out how we can write the function factorial. This is what it is written in the main. Now once the function is, when a program is written like this, it will start execution from the main, and it will find the function call here, is a function call here. So the control will search for the function definition, that is nothing but we have to describe the function neatly with the step-by-step procedure, and the control will go to function definition and it will start its execution. Here in the function, the function return type is an integer, since it is returning the result value back onto the main. And then we are finding the factorial, and n is nothing but user given value, say for example 4 or 5, whichever the number to which the user want to find the factorial. Now the first condition, if suppose n value is equivalent to 0, then what it need to return? Return is the special keyword which will return the given value, whichever we are mentioning. Normally we will specify the integer value which will be returned from the point it was called. That is, in the sense, it will be called to the main function in our example program. Next, here the template what we follow here is, in the if condition we will write the termination state, that is when n is reaches to 0, it will return in the value 1. And else the main condition, main statement, that is nothing but recursive statement we are writing here. That is, we have found that the function that is n into factorial of n minus 1 will yield a recursive function, and we can write the recursive statement like this. That is how it will be worked with the value n, whatever it is given. Say for example 4 is a statement that is entered by the number entered by the user. Then 4 is double equal to 0? No, the condition is false. So it will come inside this else part and it will start computation 4 into, and here we could see once again the same function will be called. When it sees like this, the control will start execution once again from here onwards with value what? N into factorial of n minus 1. That is n we took it as a 5. So fact of 4 will be called once again. So this set of steps will be keep repeated continuously. This is how this will be going to execute it. Now if we took if we consider this with one example, we have started with n equal to 4 and we have declared the result as well in the main function, and in the main there is a function called as factorial of 4. The n value is nothing but now 4. With the 4 value, the function factorial is called. When it is called, the control will go to function definition. That is what we have defined in the here. This is a set of code that we have written inside the function factorial. This is what we call it as a function definition. So from there the execution will begin. That is, first it will check with the if condition. N is nothing but now 4. 4 is double equal to 0. No, the condition is false. It will come to the else part and it finds 4n into factorial of n minus 1. That is nothing but 4 into factorial of n is 4 now. 4 minus 1 is nothing but 3. So here this is what we are calling it as a recursive function. This is the main function. From there we are calling once again the same factorial function with the value, now with the value 3. This is what we are calling it as a recursive function. Same function is called inside the main function, that is factorial function. Now what will happen? It will go inside once again with the same factorial function, but n value is equivalent to 3 now. So control will move whenever it sees like this to this particular statement with I value is equivalent to n value is equivalent to 3. Whether 3 is equivalent to 0? No, the condition is false. So it will come to the else part and it will be evaluating return 3 into factorial of 3 minus 1, that is 2. This is once again a function call. So it will once again move to the function factorial with the n value is equivalent to 2. Now checks 2 is equal to 0. No, the condition is false. Comes to the else part, 2 into factorial of 1 is going to be computed. This factorial of 1, when we write it, it is nothing but it is once again calling the function factorial with n value is equivalent to 1. This is how it is called once again. Now it checks whether 1 is double equal to 0. No, condition is false and it moves to the else part and it finds 1 into factorial of 0. Factorial of 0 is also once again the function call. Now it will execute this function with n value is equivalent to 0. It checks the condition. 0 is double equal to 0. Yes, the condition is true. And now it returns 1. Where it is returning? It returns to the previous step. That is from which point this function fact is called. That is nothing but to which location, to this particular location, the value 1 will be returned. This is the main point, how it will be returning the value after calculation in each step back onto the main function. Now, with the return value 1, it is going to return to the previous point from where that function is called. Now, the value returned is nothing but 1. 1 into factorial of 0, it computed as 1. 1 into 1 is nothing but 1. To where this 1 need to be returned? It need to be returned to the previous iteration from where that factorial is called. That is 2 is here. It will be returned to this particular location. That is nothing but return 1. This is the point where it has been written. This is returned to here. And this 1 is returned from here to this. And then after this 2 need to be returned to the previous iteration, that is 2 here. This is the 2 what it is written. Now it computes 3 into, this is what we are computing, 3 into factorial of 2 is computed and it is cached from this particular location. And now what is the value it need to return? That is 3 into 2 is 6. It need to return to the previous step. That is from the point from where this function is called. 4 into factorial of 3. Now factorial 3 is replaced by the value whatever it is calculated and returned by this function. Factorial 3 and it is nothing but 6. So 24 is a value it is computed. Now that is nothing but 4 into 6 is the value of this factorial 3. Now the final result it computed is a 24. Now to where this 24 is returned, that is returned to the main function as a final resultant. That is to main, it will return the value of this factorial of n, that is fact of 4 as result as 24. So the final resultant is containing the value as 24. This is what it is printed as a final factorial of a given number by the printf statement. This is how at the back end these recursive functions are going to be worked. So what is the termination condition we found here? And that is when it reaches the value, n value is equal to 0, it terminates and it is going to return the value to the point from where that function is called, and it is calculating the final result based on that. This is how in the back end the function is going to work. I hope it is clear why we have written the statement as n into factorial of n minus 1. That is nothing but we can able to find the factorial by referring to the factorial of a previous number which was already calculated in the previous step. That is what we have done in this process. This is how we can find the factorial of a given number. Next program is write a C program to generate n Fibonacci series using a recursion. Even this Fibonacci series I have already discussed in the previous video lecture. What is Fibonacci series? How we can generate this using the for loop. Similar to that, but we are using the recursion function now. What is the Fibonacci series? Or this is we are getting the next term by obtaining the sum of previous two terms or the numbers. That is, your Fibonacci will start from 0 and 1 are the constant that we normally refer it as first two values, and then the next element that we are getting is addition of previous two numbers, that is 0 plus 1 will yield 1, and same way 2 is obtained by 1 plus 1. That is, we can write one generalized statement which will help in a calculation of this Fibonacci by referring to recursion is we can write here as Fibonacci is a function that we are using to write the logic for finding the Fibonacci, where we can write Fibonacci of n minus 1 plus Fibonacci n minus 2. So this is what we are computing by using this we are computing the next Fibonacci value. And here a recurrence relation that we are coming across is first for n value if it is 0, if n value is equivalent to 1, then the Fibonacci series is nothing but the value is 0, and if n value is equivalent to 2, then it is nothing but 1. These are the first two conditions what we can come across. And then the major statement that we are writing to find the Fibonacci series is we are referring to the previous two numbers addition. That is, we can write in general as fib of n minus 1 plus fib of n minus 2. That is the previous two numbers we can in general we can refer. This will be computed if n value is greater than 0. So these are the three different conditions we will come across. If you look into the code, how we are writing this, we will start with the header file. Next, after that the function declaration or function prototype is written. Here the return type is integer, fib is the function name, and it takes the argument or the parameter as n. This is nothing but number to which we have to generate the Fibonacci series. And inside the main, we have defined the variables k, I and x. K is the value of n, and then n value or the whatever how many numbers the user want to generate the Fibonacci series is referred by variable k, and I is a variable which is used to process through the Fibonacci series, that is using the for loop, and then x is a variable which will hold the final result. Now coming to the main generation or display of Fibonacci series. That is, here Fibonacci series is not a single one element. It is nothing but a set of elements. In general, we are printing a more than one value. So we want a looping statement. That's why I have opted here the for loop, and it will start from 1 onwards. And how long it will execute till I value is less than or equal to k. K is nothing but number whatever it is taken from the user, and I is keep incrementing. And inside this, what we have to write, the function call which is responsible to compute the Fibonacci series we have to write. Normally in the previous ways what I have discussed, inside this for loop we used to write the logic which is required for generating the Fibonacci series. Now we have separated it with a separate function. So function call need to be written in this loop. So here x equal to fib of I. I will begin with 1. So if fib of I is nothing but fib of 1. This is how the function is called. And after that, obtaining this x value, whatever the value written by this fib, it is going to be displayed as a final result. Next, we'll see the function call, function definition. We have seen the function call. Now coming to the function definition, the return type is integer, function name is a fib, and it takes the parameter n, that is entered by the user. Value entered by the user. Whichever the I value is there, it will be stored in this n now. Here what we are referring in the previous step, this we have mentioned as a fib of I. The value I, whatever we are going through, will be copied into the variable n. Please note, this is what we are calling it as a calling function, and this is what we refer as a called function. From calling function, the value will be passed to the called function. That is, I value, whatever we are referring, will be obtained by this n. I will start from 1 onwards. If n value, that is I is mapped to n now. That is n, if n is, we can write like that, no harm. We'll discuss in more detail in the next session regarding that, what is formal and the actual parameters. Now, if n is double equal to 1, then what we have referred, it is written in the value 0. If n is equal to 2, then it returns the value as 1. This is a second condition that we have written. And the third case, that is else, in this it need to compute the factorial. How we can compute? By referring the previous two numbers that we have generalized and wrote, right? Fib of n minus 1 plus fib of n minus 2. This is nothing but the recursive function. How it will work? That is, here fib is a function call. Once again, this is a function call which will be connected to once again the same function. Plus, this is also will be connected to the same function. This is how it will be referred as a recursive function. The same function is called from the fib function. Now, Moving to the output, enter the value of n. The user has entered the value as 4. So it generates first I value will be equivalent to 1. Yes, n is equivalent to I value is n. 1, sorry. So 1 is copied to n. So now n value is equivalent to 1. It returns the value 0 to the main. Next, I value will get incremented. I value will be 2. So 2 is double equal to 2. Yes, condition is true. So it returns 1. And then comes to the next condition, that is computation of Fibonacci of n minus 1 plus fib of n minus 2. We'll see that these are the in detail now. Here the series what it printed is 0, 1 and 1 and 2. We'll see how it computed the next two values. The major logic that we generalized formula that we use here is fib of n minus 1 plus fib of n minus 2. That is previous two numbers addition we are finding and we are printing. Now let me take the value of n as 4. So it will move to the I for loop with the I value equal to 1. I is less than or equal to n. It is nothing but 4. I plus plus, and it needs to print the Fibonacci of fib of I. And now inside this, when I value is equivalent to 1, what it computes, it called the function fib with 1. What is the value if I value is equivalent to 1? We have written it as a 0. And if I value is equivalent to 2, what is the return value? It is nothing but 1. Now, I value will be equivalent to 3. That is nothing but n value is equivalent to 3. I value is mapped onto n value or copied onto n value. So, fib function is called now with the value 3. Now, it generates, it will not match to the first if and else if. So, it is coming to the else part. In the else part, there is a statement fib of n minus 1 plus fib of n minus 2 with the return. So, here it refers fib of 2 plus fib of 1. That is, we have, it is already computed fib of 2. What is the fib of 2? Once again, this fib function is called with the n value as 2. So, it is referred previously. What is the value of fib of 2? It is nothing but 1. It prints. And what is the fib of 1? It is already computed. So, it is referred as 1. Next, it is going to compute n 1 plus 0. It is nothing but 1. So, the next series value present in the Fibonacci series is obtained. Next, moving to the I value as 4. Now, n value is nothing but 4 now. It is going to the condition, first two if and else if is not matched. So, it is moving to the else part. In the else part, there is a condition as return of fib n minus 1 plus n minus 2. So, it checks fib of 3 plus fib of 2. Are we computed this fib of 3? Yes, this is nothing but fib of 2 plus fib of 1. This is what we refer as a Fibonacci series which that we generate is by using a recursive function. That is, internally it will keep calling this function. Fib of 3 is nothing but fib of 2 plus fib of 1. And it computes the fib of 2. This fib of 2 is nothing but value 1. And fib of 2 is once again here also it will return it as value 1. Fib of 1 is nothing but 0. Fib of 2 is 1. And it computes the sum of all three numbers. That is 1 plus 0 plus 1. So it is yielding the final value as 2. This is how we generated with the series as 0, 1, 1. And 2. Initially, when I value equal to 1, the first if condition is matched and it printed 0. When I value is equivalent to 2 and n is run with the value 2 and it is obtained the value 1 and it will be printed from the main function. and I is getting incremented, and when it is 3, fib 3 is computed by fib of 2 and fib of 1 addition of. This is obtained by performing the recursive function call. This is how the recursion will work. In the backend, these recursions are when the function is called or when the main function is called. Normally in the memory, in the RAM, there is something called as a stack memory. There some location or the space is provided to execute this function. Normally these recursive functions are executed in the stack. So whenever these functions are working there, it will make changes to all those variables values, and it will be finding the result, and it will return back to the main. This is how we can compute the Fibonacci series by using the recursive function. The main observation here is, first we should identify what is the recursive statement need to be written, and then what is the condition we have to specify, and the main function to call that function where we have written these two conditions. Next program is to find the binomial coefficient, that is nothing but NCR using a recursion. This is also we have come across to find the binomial coefficient table. Here we are just finding for the given n and r value, we are finding the binomial coefficient. There is a formula, well-known formula, that is n factorial divided by r factorial into n minus r factorial. When we write like this, can we observe anything? Yes, this n factorial is nothing but what we have already discussed, that is factorial of a given number. We can write that same logic we can use to find the factorial of a given number. And once again we are computing the factorial of r, that is only this variable name is different, and then once again this is nothing but n minus r factorial. We can refer it once again by using the same function. So this is the recursive statement what we use in the functions. We'll see an example now, a program, and after that with the example we will try to understand. Here the main is started with, so we have written the function prototype, the function declaration with the integer as a return type, and fact is the function name, and it takes the argument n, that is the user given value. Now it takes the value n and r from the user, and the main condition it need to check is n is greater than r. If it is true, here it need to call the function, that is result equal to fact of n, factorial is the function that we need to write, divided by factorial of r into factorial of n minus r. This is the formula that we referred with to find the binomial coefficient. The same we are using with respect to recursive statement, recursive functions, and we are printing the result. This is what if the n value is greater than r. Else part, the error statement that we are writing, that is n should be greater than r. And coming to the factorial function, here we know that it takes n value from the user, and it calculates if n value is equivalent to 0, it returns the value 1. As we know, factorial of 0 is 1. And then else part, it will compute n into factorial of n minus 1. This is the same code that we have referred previously, so that it will be keep executing this. Next, after this, it will be this process will be keep processing, that is first when we write factorial of n, the same function is called with value n, and here divided by, here we are calling this fact r. Thus r is nothing but same value whichever entered by the user. The same function is called now with the r value, and then into factorial of n minus r. This n minus r is nothing but whatever the user given n and r value, it is a difference of that, and with that once again same function is called. With this statement we are calling the same factorial function with a different n value, or it may be different r value and n minus r values. The same function is referred, and each time inside that we are finding the recursive statement. That is here if we analyze that the code, if suppose n equal to 4 and r equal to 2, how it will check? First 4 is greater than 2, yes, condition is true. Here it checks the condition and this statement will be going to execute it now. That is factorial of n divided by factorial of r into factorial of n minus r. Now n is 4, r is nothing but 2, and n minus r is nothing but 2. All these are nothing but a functions. Now everything here what we need to refer is this, it is referred to the same function fact with the different n value. Here the value is 4, here the value is 2, and this is the value 2. The same function is referred with the different n value. How it will process? That is first time when factorial, for this it is computing the result. That is when n equal to 4, it returns the value 4. As we discussed factorial of 4, how it is going to execute, the same process it will perform, and the value returned is nothing but 24. After that, it will compute factorial of 2. We know that it will, when it finds factorial of 2, control will move to the function definition. Here, fact of 2, it will be called. Now, it will return 2 into factorial of 2 minus 1. That is nothing but 1. So, it will compute the result and it returns, as we know, factorial of 2 is 2. The same process it will be repeated, and once again here the factorial of 2 will be computed and return the result as 2. So as a final statement, this factorial of 4 is returned with the value 24, and factorial 2 returned the value 2, and this once again factorial 2 returned the value 2, and that is 2 into 2, it will return the compute the result as 4. So it finds 24 divided by 4. That is nothing but the total final resultant as a 6. That is 4C2. NC2 what we refer. That is in 6 different way we can perform the combination of a given n numbers. That is 4. This is how we can find the factorial very easily by using the recursive statement. These are the 3 different well-known examples and important programs which will be asked repeatedly to find the any given computation by using the recursion. Here the types of the recursion. Here there are 2 different, the way how the recursive function is called, based on that it is classified into 2 types. One is direct recursion and one more as a indirect recursion. We'll try to understand what is this direct recursion. The process where the function calls itself in a very directly. That is, if you refer to this function 1, this is the function. Inside that the same function is called in a very direct manner. This is what we call it as a direct function. What we have discussed previous, all the programs are all example for direct function. Inside the fact, we are calling once again the same function. Next, coming to the second type, that is indirect function. Here, this is the process where the function calls some other function and that function calls back the original function. In simple terms, for example, there is a function A and A calls the next function B and B function calls C and C once again if it calls A, then those function we call it as a indirect functions. If we see, like if we look into here with this example, inside the function 1 there is a call to the function 2, and in the function 2 there is a call to the function 3. Inside the function 3 once again there is a call for the function 1. This is how it is in a indirect way it is calling the function. These are the two types of the function. So in this lecture video, I have discussed majorly about what is function and how we can perform this recursion with respect to function. And we have looked into 3 example programs. All are important. With code you have to write the program and then the corresponding output what it is expected for that. Thank you for listening.